Hi guys, welcome. And then we're going to start here by talking a little bit about Newton's laws of motion. So let's go over your do now. Remember to write the question in the left-hand column and your correct answer in the right-hand column. Okay. Charles rolled a ball across the floor and noticed that it stopped before reaching the other side of the room. A force applied to the ball in the opposite direction in which it was rolling caused this to happen. What is the name of this force? So think about this. If you check your answer and your correct answer is friction, you are correct. Friction is the name of the direction that is the name of the force applied in the opposite direction. So this gives you a little bit of information just about friction, and friction is something that we will talk about a little bit in discussing Newton's laws of motion. So let's talk about Newton's first law. So we have discussed this in class, and you have taken notes on it, but we're just going to review it quickly before we get into looking at some examples. So Newton's laws of motion. The law of inertia is the first law of motion. Its definition states that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an external force. So an example of this. So you kick a soccer ball, it will roll until it is stopped by friction or by another object. Newton's second law of motion, also known as the law of acceleration. There are three main ideas. It's the law of acceleration, that the larger a force makes a proportionally large acceleration, and acceleration is inversely proportional to mass. Therefore, an example of this, if you use the same force to push a truck and to push a car, the car will have more acceleration than the truck because the car has less mass. Therefore, force is equal to mass times acceleration, which is the formula that we use to find out the answer to questions within Newton's second law. The third is Newton's third law of motion. For every action, there's an equal and opposite reaction. An example of this is how swimmers start off in a race. Okay, the picture I have at the bottom there shows you someone jumping from a boat, which is similar to the action of a swimmer trying to start from the beginning of their race. So the person is jumping from the front of the boat, therefore they're jumping in the one direction, they are pushing off, and the boat is going in the opposite direction. There you have your action and the reaction to your action. So here we have, this is what is occurring here, Newton's third law of motion. We're going to go through some various examples. What I'm going to do is I'm going to read the question for you. Some of them will be about Newton's laws of motion or concepts related to it. So I'm going to read it. I'm going to state at the end of reading the question that you should pause the video. You will pause the video, and once you think you know the answer or you are correct, you should start the video back up. So, which law describes what happens when a tablecloth is pulled out from under a setting of china without damaging it? Pause the video now. The correct answer is the first law, Newton's first law of motion. Question 2. Which law describes what happens when two skaters push apart in a rink? Pause the video now. The correct answer is Newton's third law. For every action, there is equal and opposite reaction. Which law relates acceleration to mass? Pause the video now. The correct answer is Newton's second law. Force is equal to mass times acceleration. F equals blank times A. Fill in the blank to complete the equation for calculating force. Pause the video now. The correct answer is mass. Good. Those were just a few examples of questions you may see relating to Newton's laws of motion. Thank you guys for checking in and checking this video out on Newton's laws of motion. I look forward to discussing more in the future. See you guys later.